Our goal is to calculate the limit of the x, root of x, as x goes to infinity. Or this guy can be written as the limit of x to power 1 over x. If we decide to use direct substitution, basically you have infinity raised to power 1 over infinity, which is infinity to power 0. Guys, it's a common mistake that students say that, hey, any value raised to power 0 is equal to 1. It is not. It's a common mistake. We see different things on exam or homework, and students come up with initiative ideas, creative ideas to solve these kinds of problems. As long as you see infinity to power 0, this is indeterminate form. When you have indeterminate form, one of the approaches is to simplify as much as you can, use conjugate or use ln or other techniques. So in this case, since I see an exponent here, I prefer to use ln. So let us use ln to simplify x to power x 1 over x. So let us call this guy y. So y is equal to x to power 1 over x. We take ln of both sides. When you take ln of both sides, you get ln of y equals to ln of x to power 1 over x. From algebra, remember that if you have a quantity like u to power n and it is ln of that quantity, we can take n and write it in front of ln. So you have n times ln of u. So this n here is 1 over x. You're going to write it in front of your ln. So ln of y on the left-hand side is equal to 1 over x times ln of x. Okay, now that you rewrote x to power 1 over x using ln, what happens if you take the limit? So if you start analyzing this, the limit of ln of y as x goes to infinity is equal to the limit of 1 over x times ln of x as x goes to infinity. So limit of ln of y as x goes to infinity is equal to, well, 1 over infinity is 0 times ln of x as x goes to infinity times infinity. So again, you have indeterminate form, but you can't apply L'Hopital's rule here. So this is another indeterminate form. But remember that if you can write it, note that if you have 0 over 0 or infinity over infinity, then you can apply the L'Hopital's rule. So how can I convert 0 times infinity to 0 over 0 or infinity over infinity? I'm going to write x on the denominator of ln of x. So if I write this guy as ln of y stays the same on the left-hand side, equals to ln of x divided by x. And when you take the limit, as x goes to infinity, you have infinity over infinity. Now, if you take the limit of ln of y as x goes to infinity is equal to the limit of ln of x divided by x as x goes to infinity. What's the meaning of that? It means that you have the limit of ln of x as x goes to infinity divided by the limit of x as x goes to infinity, which is indeed infinity over infinity. We are happy here. Why? Because now we can apply the L'Hopital's rule. Guys, you are not applying L'Hopital rule on the left-hand side. Left-hand side has nothing to deal with. On the left-hand side, you just copy down the limit of ln of y. Let me change the color of ln to highlight that we have indeed ln involved here. As x goes to infinity must be equals to the limit of the derivative of ln of x divided by the derivative of x as x goes to infinity. This was basically the technique of using L'Hopital's rule, because if you have infinity over infinity or 0 over 0, then the limit of f of x divided by g of x as x goes to a is the same as the limit of f prime of x divided by g prime of x as x goes to a. This is basically L'Hopital's rule. Okay. From calculus, remember that the derivative of ln of x is equal to 1 over x. So I'm going to copy down the whole thing. Limit of ln of y as x goes to infinity is equal to limit of the derivative of ln of x, which is 1 over x, divided by the derivative of x is equal to 1. So you get 1 over x divided by 1 as x goes to infinity, but this is 1 over infinity or 0. Well, what happens here? I have limit of ln of y equals to 0 as x goes to infinity. It means that ln of y is equal to 0. It means that y is e to power 0 or 1. So we found the limit of the function that we were working with. What was our function? Our y was equal to x to power 1 over x, or the x root of x. The limit of y as x goes to infinity is the limit of the x root of x as x goes to infinity, which indeed is equal to 1.